Hi, this lesson is about solving application problems by using systems of linear equations. So we're going to focus on two types of problems. These are called rate of wind or rate of current word problems. And we'll be using a familiar formula, rate times time equals distance. And the other one are mixture word problems, which again uses a familiar formula, amount times cost equals total. But in both cases, you'll have two variables, and oftentimes these make more sense to solve with the addition method or elimination method, but again, they can be solved with substitution as well. So let's start with rate of wind or rate of current. As I mentioned, you'll be using this formula, rate times time equals distance. But there'll be some other things you need to keep in mind with these types of word problems. These problems will have to do with an object traveling either in the air, it could also be on land, where wind is a factor. When you're traveling with the wind, that makes the object go faster because it's propelling the object forward or helping the object to move forward. But when you're going against the wind, it slows the object down. And the same is true with something in the water. So rate of current problems would be an object in the water. When it's going with the current, the object moves faster. When it's going against the current, it slows it down. So if we let x be the rate of the object, whether it's a plane or a boat, etc., the y is going to be either the wind or the current. So traveling with the wind or current, you're going to be adding these two variables. Your rate will be x plus y when the object is going with the wind or the current. And when it's going against the wind or the current, the rate will be x minus y. So you subtract them because, again, it slows the object down when you're going against the rate or current. All right, so if you can remember this, it really helps to set up these problems. These are actually easier than the uniform motion problems we did a while back in this course. So we have a plane flying with the wind that flies 1,000 miles in 4 hours. Flying against the wind, it takes 5 hours to travel the same distance. Find the rate of the plane in calm air, and remember, that'll be the x value, the object, and find the rate of the wind, which will be the y value. So as I mentioned, when you're going with the wind, your rate is x plus y. Against the wind, it's x minus y. So that's what you see here in this table. You're told it takes 4 hours going with the wind, but 5 hours going against the wind, and it travels 1,000 miles. So your distance column is rate times time. So I have 4 times x plus y. And remember, the distance is 1,000 miles. And then against the wind, it's the same distance, but it's 5 hours. So it's 5 times x minus y equals 1,000. So this is our system of linear equations. Now, to make things easier on us, 1,000 is divisible by 4, and it's also divisible by 5. So that's exactly what I'm going to do. I'm going to divide equation 1 by 4 and divide equation 2 by 5. When I say divide the left side and the right side. So on the left side, you get x plus y, and on the right side, you get 250 for the first one. And for the second equation, you get x minus y and 200. All right, so that now I'm ready to add these two equations. So this system here is perfect for the addition method because when I add, my y's will cancel. So I get 2x equals 450 divided by 2, you get that x is 225. Remember, x is the rate of the plane. Now we need to find out what the rate of the wind is. So I'm going to plug in here. You can plug in any equation you want, but this one seems pretty easy to work with. So I plug in 225 for x. I subtract it from both sides. You get that y is 25. So the plane is traveling at 225 miles per hour, but the wind is traveling at 25 miles per hour. And that was the question, so you're done. All right, let's look at another example. This one's about a boat. So a boat traveled 108 miles in 3 hours, traveling against the current and traveling the same distance. It took 1.5 hours with the current. So again, it's a really similar problem. We have with the current, that's x plus y, time is 1.5. Against the current, remember your rate is x minus y. This column will always be the same in these rate of wind or rate of current problems. It took 3 hours, and the total distance going to is 108, and also coming back, it's also 108. So here are our equations, which I've rewritten here. All right, so rather than dividing by 1.5 and by 3, which you could do, I'd rather not work with the decimal. I'm just going to go ahead and distribute. That will work as well. So when you distribute the 1.5 and the 3, you get this system here, which again, if I want to solve, you can solve by either the addition method or the substitution method. I decided to use the addition method, so I'm going to multiply equation 1 by 2 so that my middle term here turns into a positive 3y, and therefore my y's will cancel when I add. So my new equation 1 is 3x plus 3y equals 216, and the second equation just gets copied down and rewritten below the new equation 1. So now I'm ready to add these two equations, and as I mentioned, the 3y's cancel, but 3x and 3x become 6x, and the right side, 216 plus 108 is 324. Divided by 6, you get that x is 54, and that's miles per hour. That's the speed of the boat. Now I need to figure out what the speed of the current is, so I decided to plug into equation 2. So I'm plugging in 54 in for x and solving for y. And when you do, you get that y is 18 miles per hour, and that is the rate of the current. All right, so the other types of problems are called cost mixture problems. And in these problems, we'll be using the formula amount times cost equals total. And so these types of problems will have to do usually with two different transactions or purchases happening, where you're able to set up one equation for one transaction and another equation for another transaction, and then those two equations create your system. So here's our first example. It's about different types of wood. So it says a contractor purchased 50 feet of redwood and 70 feet of pine for a total cost of $268. He then made another purchase at the same prices of 80 feet of redwood and 60 feet of pine for a total cost of $356. All right, so let's talk about the first purchase. The contractor purchased 50 feet of redwood and 70 feet of pine. We don't know what the cost of each one is. That's actually the question. Find the cost of each type of wood. So I'm going to call one cost X, the other one Y, because they're probably different. Redwood is usually more expensive than pine. But you do know that you spent $268 on that purchase. So remember, in the total column, it's amount times cost. So 50X is the cost of the redwood, 70Y is the cost of the pine, but the total cost is $268. So you add those two amounts and you set it equal to $268. So that's actually your first equation, 50X plus 70Y equals $268. All right, now let's use the information to set up my second purchase. Again, redwood and pine, 80 feet of redwood, 60 feet of pine in the second purchase. This time the contractor spent $356. So here's our second equation, 80x plus 60y equals 356. And again, the x and the y, that's the cost per foot of each type of wood, which we're trying to figure out. All right, so I've rewritten those two equations right here, called the first purchase my equation 1, and the second purchase, my equation 2. So again, I decided to use addition method or elimination. And the variable that I want to eliminate is the x variables. You can also do the y variables. I just chose x. So the LCM for 50 and 80 is actually 400. So remember, the LCM for 5 and 8 would be 40. So it just has another 0 attached to it. So it's 400. So the first one gets multiplied by 8. And the second one I'm multiplying by -5 because remember, I want the signs to be the opposite. So my new equation 1 is 400x plus 560y equals 2,144. And my new equation 2 is -400x minus 300y equals -1,780. When I add those two equations, my x's cancel. My y's, 560 minus 300 gives me 260y. And my constant is 364. Divide both sides by 260. And then remember, you're looking to figure out the cost per foot, so you want to express it in dollars and cents. So if you divide these two numbers, you get $1.40 per foot. And remember, Y represents the pine. So it's $1.40 per foot for the pine. All right, so let's figure out what our cost is for the redwood because we need to know both. I'm going to plug in the $1.40 into either equation 1 or 2. I decided to plug it into equation 1. So I have 50x plus 70 times 1.4 equals 268. 70 times 1.4 is 98. Subtract 98 from both sides. You get 50x equals 170. Divide by 50. And again, express it in dollars and cents. You get $3.40 per foot. So your answers are here in the box. $3.40 per foot of redwood, that was your X, and $1.40 per foot of pine, that was the Y value. All right, so here's another example. This has to do with units of electricity and gas. So in March, a homeowner used 200 units of electricity and 110 units of gas for a total of $69.20. So that's what the homeowner owed in March. In April, the homeowner used 220 units of electricity and 200 units of gas for a total of $85.60. We want to find the cost per unit for both the electricity and the gas. So here's the homeowner's March purchase. The amount column has the 200 and the 110. Again, we're trying to figure out what's the cost per unit. So there are my variables, X and Y. The total column has the product, 200X plus 110 Y equals the 6920. So that's my first equation that you see here below. And then my April purchase is here. And again, I have 220 units of electricity, 200 units of gas. I don't know the cost. That's what I want to find out. So there's your X and Y. And my total is 220X plus 200Y equals 8560. That's my second equation. All right, so again, I need to solve this, and I'm going to use elimination or addition method. So I need to find an LCD or an LCM for either X or Y. I decided to use the Y's. It really doesn't matter which one you choose. So the lowest common multiple for 110 and 200 is 2,200. So I need to multiply equation 1 by 20 and equation 2 by -11. And again, I'm making it negative so that the signs will be opposite. Therefore, when I add them, the y's will cancel. So my new equation 1 is 4,000x plus 2,200y equals 1,384. My new equation 2 is -2,420 minus 2,200y equals negative 941.60. So I add those, I get 1,580 equals 442.40, divide by 1,580. And again, you're looking for a cost, so you want to express it in dollars and cents. This works out to be 28 cents a unit. And remember, X is my electricity, so it's 28 cents per unit for electricity. Now I need to solve for the cost per unit of gas. So I'm going to plug into one of the equations, and I chose to plug into equation 2 to solve for y. So I get 220 times 0.28 plus 200y equals $85.60. And then you end up here with y is 24 over 200. Again, solving it and putting it in dollars and cents, you get 12 cents a unit. So 28 cents a unit for electricity, 12 cents a unit for gas. So that's your lesson. Give the homework a try. Good luck.